Sounds correct.
So moving ahead with the next question, children. If m is the mass of a body and E is kinetic energy, then its linear momentum is. Again, the same formula, children. So whatever we have found earlier. So what we have considered, momentum formula is mass into velocity, or velocity equals to P by M. Similarly, the formula for kinetic energy is equals to half mv square, and this is equals to half m into, instead of v, we replace it with p by m whole square, which is equals to half m p square by m square. So, simplifying further, we get the value m, 1m gets cancelled. Hence, you are left with the p square by 2m. But given that E is its kinetic energy, so instead of kinetic energy, what I have to replace with E. So finally, how much is the value? E is found to be P square by 2m. Relation between E and P square is energy, kinetic energy, and momentum is this thing. Bringing the 2m here, we have 2me is equals to P square, or P can be written as, P square is this value, means P is equals to under root 2me. P is equals to under root 2me. Therefore, fourth option must be true, 2me. So now, the 12th question. Kinetic energy of a body of mass 1 kg is 12.5 kg meter square per second square. So, given the value of kinetic energy and its momentum in its units of kg meter per second square is, children, what is the formula for momentum? It's equals to 2mk. Yes or no? Okay. Whose values are given as mass of the body, given condition. Mass of the body is given as 1 kg. Whereas kinetic energy of the body is given as 12.5 kg meter square per second square. So, this is the given data. Mass is 1 kg, kinetic energy is this. Substituting all the values, we have momentum can be found out as 2 times of mass is replaced with 1, kinetic energy replaced with 12.5. Or P is equals to 2 into 12.5 is found to be 25, or P is equals to 5 kg meter per second. Therefore, the correct option is 5 kg meter per second. That is, option 2 must be true. 5 kg meter per second. Okay. So, moving ahead with the next question, 13th one. What will be the kinetic energy of a ball of mass 10 grams and momentum 1000 grams centimeter per second? See, clearly mass is given in CGS system grams. Momentum is also given in grams centimeter per second CGS system. Options you were given in joules as well as ergs. Let us clearly try for the solution. Okay. First of all, more number of CGS units is, let us try to solve the same in CGS units. They are asked you to find out. What is the formula for kinetic energy? Formula for kinetic energy is P square by 2m. Kinetic energy is P square by 2m. So, what is the given condition, children? Given mass of the ball m is equals to 10 grams and momentum of the ball P is equals to 1000 grams centimeter per second. Substituting those values here, we get the value of kinetic energy as P square. P means 1000. So, 1000 square upon 2 times of mass is 10. After further simplification, 3 zeros upon 2 times of 1 0. So, simplifying this, 0 and 0 gets cancelled. So, you are left with, this 2 also goes 50 times. Now, it will be simpler. So, 50 times of 1000 can be written as 5 multiplied by 4 zeros, 1, 2, 3 and 4. 4 zeros, or this can also be written as 5 times of 10 power 4 ergs. Because it is in CGS system, you have to replace in ergs. So which one is the correct option, children? Second option is correct. That is 5 into 10 power 4 ergs. But here if you check your third question, it was given in joules, and let us see whether it is correct or not. How can, if you are getting 5 into 10 power 4 ergs, it can't be 5 into 10 power 4 joules. Okay. Joules means how much? 1 joule equals to 10 power 7 ergs, or 1 erg equals to 10 power minus 7 joules. So if you want to convert it in joules, you have to multiply this times of 10 power minus 7. Then you will be getting it in joules, or 5 into 10 power minus 3 joules must be true, but not this value. So only option 2 must be true. Moving ahead with the next one, that is percentage numerical, children. If the momentum of a body is increased by 50%, how much? 50%, then its kinetic energy increases by. So let us try to solve it. This is a peculiar question, children. Now to concentrate properly. One after the other we'll solve. It's a vast increase. 50% is very much large, so you can't use that percentage error formulas like delta K and all. Directly we'll go with that. Momentum of a body is increased by 50%. So for this, let us consider that the initial momentum P1 equals to some P. Consider initial momentum P1 equals to P. Now what it was given is momentum of a body increased by 50%. Then final momentum will be equals to initial momentum plus 50% of that initial momentum. This will go 2 times. Hence, this will be equals to P plus 1 by 2P, or this is equals to 3 by 2P. How much is that? 3 by 2P. Even this can also be calculated 1.5P. How much is that? 1.5P. So P1 is P, means P2 will be 1.5P. You are asked to find the increase in kinetic energy. If P1 and P and P2 is 1.5P, then what about kinetic energy? Then K1 will be equals to P square by 2M. Yes or no? Formula for kinetic energy. What is the formula for kinetic energy? Kinetic energy equals to P square by 2M. So first one, the value of K1 must be equals to P1 square by 2M. Say yes or no? K is P square by 2M, K1 equals to P1 square by 2M. But what is the value of P1? P. So it can be taken as P square by 2M. So what is the value of K1? P square by 2M. Similarly, the value of K2 is equals to P2 square by 2M. So what is that? P2 square by 2M. Same mass. What is P2, children? P2 square. P2 is how much? 1.5. So 1.5 P whole square by 2M. That's it. Okay. P1 square by 2M means P square by 2M. P2 square by 2M means 1.5 P whole square by 2M. Clear? P1 is known, P2 is known. K1 is known, K2 is also known. You are asked to find the kinetic energy, change in kinetic energy in terms of percentage. Then change in kinetic energy is equals to final kinetic energy minus initial kinetic energy. How much is that? 1.5 P whole square by 2M minus, previous it is K1 is P square by 2M. Okay. So this is equals to 1.5 square. How much, children? This is equals to 2.25. 1.5 square is 2.25 P square minus P square upon 2M. LCM is 2M, I wrote. So 2.25 P square minus P square upon 2M, or this is equals to P square is taken common. 2.25 minus 1 is 1.25 P square upon 2M. So change in kinetic energy is 1.25 upon 2M. But you are asked to find the increase in kinetic energy in form of percentage. In the form of percentage, the formula would be delta KE by original KE into 100. So change upon original into 100. What is the change we found? 1.25. P square by 2m. What was the original? Original means the initial kinetic energy. What was the initial kinetic energy? It was P square by 2m. So further simplification gives this P square by 2m and P square by 2m gets cancelled. Sorry. And this must be multiplied by 100. Percentage we need means multiplied by 100. Therefore, this will be equals to 1.25 into 100. How much is that, children? 125%. Therefore, the correct option is option 4, that is 125%. So, let me explain once again, children. Formula for the kinetic energy, P square by 2m. Initial momentum, let us suppose it as P. Final momentum is momentum increased by 50%. Whatever the initial value is there, additionally 50% of that you have to add. P means 50% means half P. P plus half P. 3 by 2P or 1.5P. Formula for kinetic energy in terms of momentum is P square by 2m. K1 means P1 square by 2m. But what is P1? P only. P square by 2m. K2 means P2 square by 2m. But what is P2? 1.5P whole square upon 2m. Okay. We want the percentage error in kinetic energy. That is, general formula is delta KE by K into 100. Delta KE by KE into 100. Delta KE is nothing but final kinetic energy minus initial kinetic energy. K2 minus K1. So, 1.5P whole square upon 2m minus P square upon 2m. Simplifying, you get it as 1.25 P square upon 2m. So, change in kinetic energy to the initial kinetic energy into 100 is 1.25 P square upon 2m upon P square by 2m into 100. Simplify, you get it as 125%.